next thing we're going to talk about now, these are distributions. And there are two kinds of distributions that we deal with typically in business and in finance. One's called a historical distribution. A historical distribution is simply historical observations. And the other type is called a probability distribution. And in practice, much more difficult to kind of put together. A probability distribution not only projects different possible outcomes in the future, but also the probability that each of those outcomes would actually occur. But in statistics now, you deal with probability distributions and you deal with historical distributions. The difference between the two and how you calculate the statistics now is strictly about how you calculate the mean of the distribution. Historical distributions, which we're about to go through here, but historical distributions calculate what's called a simple mean, an arithmetic mean. We're going to sum the observations, divide by n. When we do the probability distribution, you'll see that when we need a mean in that type of distribution now, we're going to calculate what's known as an expected value. That is, we're going to multiply each possible outcome times its probability of occurrence. When you multiply something together now, that's called a product. You then sum the products, and that's the mean. So these two things these two types of distributions and the statistics we calculate, these will look much different. But in actuality now, it's just a function of how you calculate the mean. Historical distributions, you calculate an arithmetic mean. Probability distributions, you calculate an expected value. What I've written on the board here now, this is indeed two separate distributions. The returns of security I and the returns of the market. And we have 6 observations for each. We're just going to play like these are quarterly returns. So one quarter, in the last quarter, when the security return was 8, the market return was 6. 4 quarters ago, when the security return was 9, the market return was 6. So these are all observations from the past, but they all are observations that happened at the same time in the past. When you calculate statistics now, the first thing you always do is calculate the mean of the distribution. Now these are historical distributions. And so the way you calculate the mean now is to calculate an arithmetic mean. We're going to sum the observations and divide by n. So for security I, if you sum all these different observations, they'd sum to 26. If you took 26 and divided it by n, that is, the mean is going to be the sum divided by n, the number of observations. So if you summed all these observations, you get 26, and you divide by the number of observations, which is 6, you get 4.33%. Now, remember from the lecture just before this now, what return do you expect in the next time period? The mean of the distribution today. So if these were quarterly observations, what return would you expect for the security to earn in the next quarter? 4.33%. We also have the historical observations for the market. Just as we did here now, we sum the observations. The sum is 22. You add them all up. Divide that by 6, you get 3.67%. What return do we expect the market to earn in the next time period? In the next quarter in this example? 3.67%. So statistically, in the next quarter, we expect the security return to be 4.33%, and we expect the market return to be 3.67%. Now, just as a statistical kind of thing now, if you asked me which one of these assets do I think is the riskier asset, I would tell you this one, the return of the security. Simply because mean return is greater than the mean return for the market. What's the price of greater return? Greater risk. So this is how you calculate the mean. What we're going to do in the next video now is show you how to calculate deviation. You will remember on that little graph, the areas above the mean line and below the mean line. Those are deviations, and I'm going to show you how to calculate that in the next